Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today, once again, we're talking about an advanced math topic. Now, this topic has a whole lot of depth, and we can go into a ton of detail in it, and we may in the future, but today we're just going to take the shallowest of dives into it. The topic today is combinatorics, so let's take a look. Okay, combinatorics. What does that mean? Well, here's a definition for you found on the internet. Combinatorics is a branch of mathematics that studies the enumeration, combination, and permutations of sets of elements and the mathematical relations that characterize their properties. That probably doesn't help at all, but basically it's basically a study of counting the number of ways you can order some things. And there are a lot of ways of counting and a lot of ways of figuring out the number of things and the way that you can order things. But this is an important thing to study in probability theory, in route optimization. So if you're trying to figure out, if you're maybe Amazon or a delivery company, how many different ways there are to deliver to a certain number of people in a certain area, that may be something you do. This is also something like the James Webb Telescope has to deal with the number of times it can change its orientation with the number of tasks that it has and the areas of the sky that those tasks are, the areas of the sky that those tasks are in. So a lot of application for combinatorics here. Today we're going to keep it really basic and try to make sure that this doesn't get out of hand. And here's the way that I usually introduce combinatorics to folks. So I ask them, what are three things that you almost always have with you? And the answer that I almost always get is your phone, your wallet, and your keys, house keys, car keys, what have you. And then I say, all right, well, let's say that you have a pair of pants that has exactly 3 pockets. So we have a front left pocket, we have a front right pocket, and we have one back pocket. And then I ask them, so does it feel different to have your phone in your front left pocket versus in your back pocket? And definitely, certainly that is different. I'd say a lot of folks would put the wallet in the back pocket. It seems like a good place for it. But if we're trying to figure out how many different ways we can arrange our phone, wallet, and keys in our pockets that we have, then that is an example of combinatorics. And so we talk about these spots. We have our 1, 2, 3 spots. Let's say we have our phone in the front left, the wallet in the front right, and the keys in the back. And so we can, if we are going to keep the phone in its spot here, then really all we can do with the other 2 spots is flip the keys and the wallet. And there's really nothing else we can do to make this different without moving the phone someplace else. So let's say we move something else to the front. Let's move something else to that front left pocket. Let's say it's the keys. So if the keys are in the front left pocket now, we could have the phone in the front right and then the wallet in the back pocket. And if we want to have some other arrangement with the keys stuck in the front left, the only thing we can do is we can flip the wallet and the phone. And then if we put, the wallet, the last remaining item, in the front left pocket, then we can do phone, keys. And then we could also do, or finally we could do keys, phone. And what this is showing you is there are 3 different things we can put in the first spot. And that first thing is taken up, and that gives us 2 options into the second spot. And then there's only 1 item left to move around in the last spot. And what we have here is 3 times 2 times 1, which is 6. And what I've defined for you here is technically a factorial. And a factorial is definitively the number of orderings of n things in as many spots. So the way that looks in common math is we use the exclamation mark. And so the way that the factorial works is you take that number and then you multiply that by 1 less than that and 1 less than that all the way down to the number of 1. So if it's something like 6 factorial, that would equal 6 times 5 times 4 times 3 times 2 times 1. And this way of thinking about numbers in multiplying down is going to underpin the way that we think about combinatorics going forward as we get to permutations and combination. And if we were to add 1 more pocket to that example that I just gave there, where we have like a front left, front right, and then we could do back left and back right, and we had 4 things. So maybe that's phone, wallet, keys, and headphones. That would be 4 times 3 times 2 times 1 spots. And you may notice that as we get more spots and we have more items, this quickly becomes very, very large. So if you think about the number of orderings of 52 cards in a deck of playing cards, that's 52 factorial. That's the number of meaningful arrangements of 52 cards. This number is actually bigger than like the entire universe. And so the number of items in factorials or combinatorics explodes very quickly and becomes very unwieldy very fast. But anyway, as I mentioned, we're going to keep this pretty general today and avoid any of the N's and P's and R's and stuff. So we have 2 example problems here. As usual, we'll look at one at a time. Go ahead and see how you do with this first one. Okay, let's take a look. So George is driving his family from their home to soccer practice. His family consists of himself, his wife, Gina, their eldest daughter, Jane, youngest sister, Erica, eldest son, Manny, younger brother, Rick. So George must be the one to drive, and the van has 5 available passenger seats. How many different ways can the family be seated in the car? And the way that you want to think about this is just the same way as the phone, wallet, keys problem. We have as many spots, 1, 2, 3, 4, 5, as we do people. And so if somebody is seated in the front spot, that means that 1 fewer person can be in the second spot, and same for the third spot, fourth spot, and fifth spot. And the way that we talk about the driver's seat is that it's just 1. There's only 1 way the driver's seat can be seated, and that has to be George. So basically that value of the 6th seat just goes away. And we have 5 spots for 5 distinct items. And 5 times 4 is 20, and then 3 times 2 is 6, which leaves us with 120 meaningful orderings of people seated in the car, because each person is clearly different. And so one person flipping with another person means it's a different meaningful arrangement of being seated in the car. All right, moving on to our second practice problem. See how you do with this one. All right, let's take a look. So Alex, Beth, A, B, C, D, E, and F are going to lunch and will be seated randomly at a circular table. What is the probability that Derek and Eric will not sit next to each other for lunch? The thing we want to do here is think more visually than anything else. So we have this circle. We have 1, 2, 3, 4, 5, 6 spots. And Derek, we're going to put here. And so what that means is that there are really, 2 places where Eric cannot sit. Eric cannot sit here or here. And, whether you spin this around or not, this is still going to be the arrangement. And we can see that Eric really has 1, 2, 3, 4, 5 different places he can sit relative to Derek. And what that means is there's 2 of those 5 spots that he cannot be seated in. So that's to say that there are 1, 2, 3 places out of 5 that he can be seated in order for him to not be sitting next to Derek. So a lot of probability to this problem, but this is also a combinatorics example. And our answer here is just going to be D, 3 out of 5. Okay, that's it for this video. As I mentioned at the top of the video, there is a ton of depth to the combinatorics topic, and this video is just meant as an introduction. So check back with us in the future for permutations, combinations, and a bit more advanced stuff. But for now, if you found this material useful, we hope that you will like and share the video and subscribe to Quiet Education. If you require any kinds of tutoring, please reach out to us. Thank you for watching, and I hope you have a great day.